started. It's a little bit harder to get everything going here, but class has started, so we're gonna go ahead and get going here. Holy moly, 5 minutes goes by really quick, doesn't it? Good morning, everybody. Yeah, 5 minutes goes by super quick. So what's the date today? 4/19/21, and what we're gonna be doing today is 8.2 day 1, and we're going to be proving similarity. So just really quickly, I wanted to do a little warm-up with you guys. So let's go ahead and do that. So let's do a warm-up really quickly, and I know people are still joining. So our warm-up today is going to be if triangle ABC is similar to triangle XYZ. Okay, I'm going to go, what if I go like this? I'm going to go 2, 4, 6, and I'm going to go 6, 12, 18. So I want you to list all corresponding congruent angles. And then 2, I want you to list all corresponding ratios of sides. And then 3, I want to know what's the scale factor. Okay, so we'll go ahead and start there. So it looks like we're missing quite a few people. So I'm just going to give you guys, let's do this. Let's do, what time is it now? I'm going to give you guys 2 minutes. Let's do 2 minutes to do this warm-up. Okay, so this is from the lesson that you guys were supposed to do on your own, right? So 8.1 was a lesson you guys were supposed to do on your own last Thursday. So good morning, everybody. We're working on a warm-up, and again, this is stuff that we did from your independent work last Thursday. So we're just taking a second, guys, to finish up this warm-up. All right, guys, so let's go ahead and go over this. If you guys have questions, please let me know. So again, today we're going to be working on proving similarity with AA. We're going to spend 2 days on that. So we're going to, so when I mean 2 days is, so the way that this new schedule is going to work, well, let's go over the warm-up and let's talk about that. Some people are still coming in. So the timer's off and let's close this up. So what we're going to talk about here is we're going to list all the corresponding angles. So the first thing that I'm going to look at, and remember from the video remember you guys were supposed to do the 8.1 homework that was due today. So from 8.1, from the video you guys were supposed to watch, is that we can label these as large, right, small, and middle, right? So that's a really good tactic. So then this is large, this is small, and this is middle. All right, so that's a really good tactic to be able to get those things. So I have small, large, middle, small, large, middle. So what I'm going to look at, so listing corresponding angles. So for example, if I start with angle A is between the small and the large side. So I look at what's between the small and the large side over here. It's Y. So I know that angle A is going to be congruent to angle Y. And so that's a neat little trick on how I can match all of those up. Okay. So next, if I go angle B, okay, so angle B is between the small and the middle. So then the small and the middle over here would be Z. So I'd go angle Z. Okay, like that. And then last, angle C, right? Well, there's only one left, so it has to be X, but we can also use the same method just for practice. C is in between the large and the middle side. So then X is between the large and the middle side. So it's going to be angle C is congruent to angle X. Okay. So that's listing all the corresponding congruent angles. Okay. Now I'm going to list all the corresponding ratios of the sides. So again, with the ratios, we're just doing fractions. And I'm going to go, and if it doesn't say, right, we're always going to assume that we're going from left to right. So this is going to be my new, this is going to be my old. So I'm always going to do new over old. Okay, so what do we have for ratios? So let's start with the smallest side. So my smallest is 6, and if I put that over this one, that's 2. And we always want to reduce. Now remember, if you're not good with reducing fractions, Desmos calculator or a physical calculator will do that for you. So for example, if I go 6 over 2, right, on Desmos or this calculator, it will tell me this is the same as 3. Okay? So again, we always want to reduce our ratios. In this case, it turns out to be, right, 3 over 1, right, which is 3. Okay, so I did small over small. So again, I always want to start with the same triangle on top. So I might go middle now. So my middle side is 12, and then my old middle is 4. Now, again, I can use a calculator, but I see, again, 4 goes into 12 here 3 times. And then I'm going to do the same thing with my large. So I have 18 over 6, and I know that 6 goes in there 3 times. Okay, so again, my ratios right here, right, it's new over old. So what is this 3 that we keep getting? What is it? Can anybody tell me in chat? What do we got? What is that 3? Yeah, it's our scale factor, right? So when it says what is our scale factor is 3. And what does that mean? It means that this, now not drawn to scale, right? I didn't draw this picture to scale, but it means this new shape is 3 times bigger than this other shape. Okay? Now, again, not drawn to scale, right? This is just for a visual aid, but this new triangle would be 3 times bigger. Now, if you flipped those ratios, right? If you did 2 over 6, 4 over 12, 6 over 18, then our scale factor would be 1/3, right? That's because this is 1/3 of this. So remember, once you get a fraction that's smaller than 1, right, that's going to be less than. It's going to be smaller. Okay. So how are you guys doing? Do we have any questions? Remember, if you haven't done this 8.1 homework, to get that done, it was due today, right? Hey, I'm glad you guys are doing well. Again, if you guys have questions or comments or you're not doing well, please let me know so I know to go slower, to spend more time on it, and to do that. Okay? All right, so today what we're going to be doing is we're going to be taking similarity to the next step. So we're doing 8.2. We're going to spend 2 days on this. Okay? So we're going to be proving similarity. Proving similarity with AA similarity. Okay, so that's what we're going to be doing today. And let me go ahead and open up my notes here so I know what to do. So AA similarity. So let's review what similar means. So similar, right, which is this tilde symbol, right? It means all corresponding angles are congruent. So all corresponding angles are congruent, and all corresponding sides are proportional. Gosh, that's a big word, proportional. And remember, proportional just means the ratios are all the same. And remember, the ratios are scale factor. Okay, so the ratios are all the same, scale factor. And that was, right, this was the lesson that you guys were supposed to do independently this last Thursday. Okay, so all corresponding angles are congruent, all corresponding sides are proportional. Okay, so how are we going to prove triangles are similar? Well, the first way to do this is it's a variety of different things. So let's say I have two triangles. Okay, just two triangles. And let's say one of these is 60 degrees and one of these is 40 degrees. And then over here, one of these is 60 degrees, one of these is 40 degrees. Okay, so to show you how AA similarity works, we have a couple of things to remember. So first, they're similar if all corresponding angles are congruent. Well, let's take a check right off the bat. Well, first of all, we have a pair of 60s and we have a pair of 40s. Okay, so we got two, right? So we're missing that last one. Well, why don't we call it AAA similarity? So, right? Like, why is it only two ways? There should be three angles, right? That's because what do we remember about the angles in a triangle? Type this into chat, guys. In chat, what do the angles in a triangle do? What do they always do? What do the angles in a triangle do? Oh, dang, you guys are killing it in chat. Oh my gosh, chat's blowing up. Yeah. Guys, absolutely. They add up to 180 degrees. So the AA similarity is a shortcut because if this is 60 and this is 40, 60 plus 40 is 100, right? So then what plus 100 gives me 180? So this would have to be 80 degrees. This would have to be 80 degrees because the triangle sum theorem. Sorry, that's a U here. There we go. Okay, because that has to be there. So right there, that's how we're using AA similarity. All we need to show is two corresponding angles are similar. So this is what we're saying. AA similarity. All we need to show, just show two corresponding angles are congruent, then the triangles are similar. I should say if, right? So I should go if two corresponding angles are congruent, then the triangles are similar. That's what AA similarity means. Okay? So already Is this easier than proving triangles congruent? Yeah, this is much easier than proving triangles congruent because we only need two things. Like, we don't even need three things, right? We just need two things. So if we can show that two corresponding angles are congruent, then the triangles are similar. Okay, and this is kind of the proof right here. So what we're going to do today is we're going to do a couple examples of this. Ooh, and now that almost, most people are here, let me break down how this new schedule, whether you're remote or you're in person, how it's awesome for everyone. Okay? So we see each other Monday, Tuesday, Thursday, and Friday. That's right. We see each other 4 days a week now. Now, why is that so good? Like, why is more math good? Because, are you guys ready to get really excited? This is the best news you're going to have all day. Because there is a chance that you guys will have no homework. What? No homework? Now, what do I mean by this? What we're going to do, like I'm doing now, is I'm going to do, what? We're going to do the lesson today just like we normally would, but tomorrow I'm going to post homework. So homework is not posted at the end of class today. Homework will be posted in class tomorrow, and you guys will show up and you'll have time in class to work on your homework. If you finish it, great, you're done with your homework. If you don't finish it, then you still have time outside of school to finish up your homework. Pretty cool, right? So it's not really homework, it's just practice. So practice will be done in class on Tuesdays and Fridays. And it's kind of like office hours because I'll be here too. So if you get really stuck, you can just ask me for help. So there should be no excuses for people not having assignments turned in. Okay? Really cool stuff there, right? So I'll remind you guys of that at the end of class today. And remember, this class ends at 12:25. So without any more fiddly diddly, let's get started on taking a look at a couple examples of how we're going to use AA. And again, we're going to spend 2 days on this, okay? We're going to spend 2 days on this. So, I kind of ran out of room. Does anybody have questions about that new format? Does anybody have new questions about the schedule or how school's working? All right. So, let's do an example of AA similarity. Okay, so here's an example. So let's say I have two triangles. And I'm going to label these. So let's say C, D, E. And then I'm going to have another triangle. And let's call this H, G, F. Okay, so I got two triangles. Hey, and if you guys do have questions, I appreciate all the feedback. I really appreciate you guys quite a bit. The more feedback, the more communication we have, guys, the better it's going to be for everyone. So just keep asking questions. If you have them, let me know. Okay, so what I'm going to do now, we have these two triangles, and I'm going to add in some angle information. Okay, so we have this, and then we have this and this. Okay, so my question is, are these triangles similar? Okay, so are these triangles similar? So remember, we only have one way to prove triangles are similar, right? So over here, I'm going to have a little, so prove triangles similar. We only have one way, and that's AA similarity. And you just do the AA with the little similarity symbol right after it. Okay? So just looking at this, are those two angles the same? Right? Just by looking. And you guys, I know because you're teenagers, you guys are going to be quick to judge, right? We're going to be like, what's going on here, right? So first off, I just want to take a look. Now, this is 90, and that's 90, right? So this triangle is congruent to that angle. But 26 and 64 aren't the same, right? 26 and 64 aren't the same angle, okay? Now, a lot of you guys are going to be really quick to write this off and be like, they're not similar. But you need to slow down, okay? What do we know about angles in a triangle? right? What do we know? What do we know about angles in a triangle? We know that the angles in a triangle add up to 180. So check this out. If I go 180 minus 26 minus 90, right? So what I'm doing here, if I call this theta, theta plus 26 degrees plus 90 degrees has to equal 180. So I'm going to subtract 26. I'm going to subtract 90. Okay, so this is what I'm doing. And I get 64. So this is 64 degrees. Well, wait a minute. This is 64. Okay, so we're going to, so notice how these two are the same. Okay. Now, we could stop there because at this point, right, we have two pair of congruent angles. But I also want to take a look at here, right? If I called this phi, so I had phi plus 90 degrees plus 64 degrees equals 180 degrees. So if I solve for this angle, right, I subtract 90, I subtract 64. So I'm going to do that in my calculator. What do we got? We're going to have 180 minus 90 minus 64. So I get, right, this equals 26. So check that out, right? So are these triangles similar? Absolutely, right? So what did we do first, right? We did the triangle sum theorem to find missing angle. Okay, so we used the triangle sum theorem. Now remember, if you're like, triangle sum theorem, what's that? Right, that just means angles in a triangle add up to 180 degrees. You can see how the triangle sum theorem is a bit shorter, right? So angles in a triangle add up to 180 degrees. That's what the triangle sum theorem is. Okay. And then 2, so we use that to find missing angles. And then 2, I can say here now, triangle CDE is similar. Ooh, look at that. Is similar to triangle. Now, corresponding parts still matter. So how are we going to do this? Well, angle C is 26. So angle C is going to correspond to angle F. D is 90 degrees, so that goes with G. And E is 64, that goes with H. And then I can say by a similarity. And I just did a proof without doing a formal proof. Okay, so I'm going to pause there for a second and see if you guys have any questions. Hey, a great question came up in chat. And the question, I mean, it wasn't a question, it was more of a comment. And it's just like, Kraft, I'm lost in geometry and I need help. Guys, so again, this schedule is really great news. So not only are we going to meet 4 times a week, so remember, I'm going to do lessons on Monday and Thursday. Tuesday and Friday are going to be like mini office hours where we're going to work on the assignment in class, okay? But not only is that going to happen, but my office hours now are from 8:30 a.m. to 10 a.m. So Monday, Tuesday, Thursday, Friday, you guys can join me and we can work on anything you need. So if you're feeling overwhelmed or lost and you're like, man, I know, like I just wasn't doing the work, or I need to catch up, or I've just been lost, my office hours are now from 8:30 a.m. to 10 a.m. And that's Monday, Tuesday, Thursday, Friday. So if you need extra help, please join me in my office hours. We can sit down, we can go over old work, we can go over new work, okay? If no one else is in there, we can talk about anything, okay? So just make sure you guys, if you need help, come to my office hours and I can get us caught up. We can get everything good, okay? And we can do that. So I hope that answers your question. I wasn't ignoring your question. I saw it. I just wanted to get to it at the end. Okay, so thank you for bringing that up. I think that's a good plan. Come to my office hours. I'll help you out. Okay, does anybody have questions about this? Did you guys see how we did this? You guys got quiet again. Yeah, and remember, guys, I need feedback, right? So even if we were in person, I would need feedback, right? The only way that school works is feedback. If we aren't asking questions or clarifying, then that's not good. So again, this is just day one, so we're just kind of doing an intro to AA similarity. So one way of doing this, right, is if you're missing some of the angles, we can find missing angles using triangle sum theorem, right? And pretty soon we're also going to find missing angles using parallel lines, vertical angles, linear pair, and all that good stuff. Okay. All right, let's have you guys try one on your own. So let's do this. So I have example 2. So this one's going to be a try on your own. So I have triangle X, Y, Z, and I'm going to have triangle T, S, R. Oops, gotta move my paper down, don't I? Okay, so I have triangle XYZ and triangle TSR, and I'm gonna add in some angles. So angle X is gonna be 21 degrees, and Z is gonna be 99 degrees, and then T is gonna be 61 degrees, and this is gonna be 21 degrees. So my question is, are the triangles similar? Okay, and I'm just going to give you guys a minute to do this. Oops, not 2, just 1. So try this out, get it written down, try it out, and see if you're getting stuck, see where you're getting stuck. Like, am I not able to get started, right? Like, it's important to know if I'm going to help you or if you're going to help yourself. Where am I getting stuck, and how do I not get stuck here again? All right, so let's take a look at this problem. So right off the bat, the first thing I'm going to notice, right, is that I notice I have a pair of corresponding congruent angles, right? 21 and 21 degrees are the same. Wonderful. Okay. But then I look, okay, I'm like 99 and 61 aren't the same. Well, maybe it's just trying to be tricky like the last one, right? So again, I'm going to note that these 3 angles add up to 180. So that is angle Y plus 21 degrees plus 99 degrees equals 180. So if I solve for angle Y, that is, I take 180 degrees minus 99 minus 21, I get 60. So this would be 60 degrees. Well, poop. These aren't the same. So we don't even need to find this other angle because they're not the same. So our conclusion here is because we need 2, right? So we would say triangle XYZ, and then you can draw the similar thing and just put a line through it. Ooh, that kind of looks like it's getting to a swastika. Okay, we're not going to do that. Put an X through it so they're not similar to triangle. Oh, that's going to be hard to do. Let's just do this. Not similar. right? Between looking like a bad symbol and being able to like, hey, what goes together? Let's just do this. Let's just say not similar. Okay, so they're not similar. Yeah, I agree. Let's avoid that, right? All right, so not similar. They're not similar. Boom. Easy peasy. You guys can do this. Now, does anybody have questions about what I'm doing, what I'm thinking? Are you guys doing okay with this before we move on to the next one? Thank you guys for the feedback. I really, right, it's really important that I know it's hard, like it's in math class can get boring, or you'd rather be somewhere else, but the more feedback you get, the better this education for you is going to be. Okay, all right, so let's go ahead and let's do another example here and see what we can do. Okay, so I got a couple of different ones that I want you guys to try out, and we're going to use some properties and see what you guys remember. Now remember, if you don't remember some of these properties, that's why we're here. We're here to learn, right? So don't get freaked out here. So let's try example 3. And I always want to give you guys a chance to try these first. So let's go ahead here, and we're going to draw a big triangle. But the key here, are you guys ready for this? So I'm going to label this triangle as A, C, D. Okay, but then I'm going to overlap, and I really want you guys to pay attention to what I just said. I'm going to overlap these two triangles so that this small triangle fits perfectly into the top of this bottom triangle. And then what I'm going to do is I'm going to say, hey, this angle right here is 52 degrees, and this angle right here is 52 degrees. And my question is, are these triangles similar? Okay, no, hold up. I'm getting lots of answers. This is really cool. I want you guys to think about it, and rather remember, in math, you can't just say it is. You have to be able to back it up. So try to figure out how you would back up your answer. Okay, whether it's yes or no, you got to be able to back up your answer. And my hint here is that the smaller triangle is sitting on top of or in the other triangle. All right, so again, we're formulating ideas. Okay, we're formulating ideas, and now we're going to talk about it as a group. Okay, so what's really important here, now some people get really confused when things are on top of things, so it might help to draw a separate picture down below. So here's E, A, B, right? That's small triangle, and then here is this big triangle, D, A, C. And so this is a trick. If you're getting stuck, because what sometimes students struggle with is their brains aren't the best at looking at overlapping images. And that's just how brains are wired, right? So it just takes practice. And one way to help your brain practice seeing overlapping images is to draw them separately and look at them overlapping. So first, notice how angle C and angle B are the same, right? So angle C is congruent to angle B, right? That's given. Okay, so it's given that these two angles, I really shouldn't call it angle B. I feel bad now. Okay, I'm going to let this one slide just because I made a mistake. But angle B and angle C. But did you guys notice this angle A right here and this angle A are the same angle? Did you guys notice that? They overlap. So this angle A and this angle A, they're the same thing, right? Remember, reflexive means when they share something. And if this triangle is fitting right here, they share angle A. So I would say angle A is congruent to angle A by reflexive property. And my goodness, guys, if you don't have this in your notes from the first day of the trimester, get this in your notes. Okay, reflexive property. Okay, reflexive property. So we have angle C is congruent to angle B. Angle A is congruent to angle A. Okay, last time I checked, that's 2. So I can say, hey, triangle ACD is similar to triangle. Well, we just found out A goes with A, C goes with B, and D goes with E. Oh, and I should say by a similarity, right? We should have the reason there. What do we think, guys? Are we doing okay? I'm breaking this up into 2 parts, so I'm trying to go slow and mellow. But right, that reflexive property, it's showing up again, and it's just showing up in a new place. So if you didn't recognize the reflexive property, that's okay. Let's get it down. Yeah, we only need 2. Isn't that hecka tight? Yeah, no, the triangles overlapping is confusing. And if you're confused by that, it's perfectly normal. That's why I'm doing this, because I know, right, from experience that a lot of people, it's hard. Our brains have to train to get good at that. Okay, yeah, and we only need 2 angles. That's just like the coolest thing ever, right? Like this is so much easier than proving triangles congruent for right now, right? For right now. Well, I think it's always easier, but all right, let's do another one of these and see. I just want to keep going. We're just gonna keep doing situational things, and then we'll go from there. All right, so let's take a look. So the next one we're going to take a look at is a bow tie problem. Okay. So sorry, this is what example is this now? We're example 4. Okay, so we have a bow tie problem. I'm going to label this S, V, R on the left, and then on the right, it's going to be V, T, U. Okay. And all I'm going to add here is I'm going to add parallel lines. So I'm going to say, are these triangles similar? Okay, so we got a bow tie problem. And again, you are looking at these and you're saying, okay, can I piece together using properties that we've talked about? And can I say these triangles are similar? Okay. Now remember, we only have one way to prove triangles similar, and that's a similarity. So you're looking for, can I show that at least 2 pair of corresponding angles are congruent? All right, guys, let's take a look at this. So this one is actually kind of fun. And I know you're like, fun, come on, Kraft. So this one's actually kind of fun because there are so many different ways to accomplish this task, okay? So this uses, okay, a lot of the same properties that we have been doing with proving triangles congruent. So there's a couple of things. So first of all, did you guys notice that we have an X here in the middle? Did you guys see that? So what happens when we have two things crossing? What kind of angles are these two? Yeah, they're vertical angles. Okay, so this was just like the ones that we did in proving triangles congruent. So then I know that this angle is congruent to this angle, right? So if I was going to write this out formally, I could say angle SVR is congruent to angle UVT, right? Because they're vertical angles. Okay, they're vertical angles. So I got a pair of congruent angles right here. And then with parallel lines, right? If parallel lines, what was the property that we were using with congruent triangles? Yeah. Alternate interior, right? So, for example, angle R would be congruent with angle T, right? So like this. Because if parallel lines, then alternate interior angles are congruent. Okay, so we have a pair of alternate interior, and this is the part that's really crazy. We can use alternate interior again if we wanted to, right? So if I have, right, these two, just trying to come up with a different symbol there, right? Angle S is going to be congruent to angle U because if parallel lines, then alternate interior angles are congruent. Okay, so it turns out, I mean, we could show all three angles are the same, right? So are these triangles similar? Oh my gosh, yeah. Now, in a proof, you would never have to write down all three. I went overboard, right? I got excited, I did all three. You would just have to pick two of the three, okay? So whether it be alternate interior or vertical angles, okay? So then we could say triangle SVR, or I'm just gonna steal from this one, is similar to triangle UVT by a similarity. Just like that. Now, again, you guys might be rusty with vertical angles and alternate interior, but that's why we're here. We're doing these examples together so that you guys can be like, oh, yeah, I can do that, right? So, again, I'm not expecting everyone just to look at this and be like, oh, yeah, duh, right? No, because then you wouldn't be here. You would have already passed the class, okay? So, again, just looking at this, these are different examples of how we can use angle rules to fill these out. And I do know we get out at 12:25. So for all my homies who are at school, I'm going to try to end at 12:23 to give you guys a little bit of time to figure out where you're going to next. And if people have questions, we can ask them a couple of quick questions at the end, okay? All right. Does anybody have questions about this? Does anybody have questions about what I did, how I did it? I'm hearing a lot from people who are getting it, but like I'm not hearing a lot from the people who are struggling. I know people should be struggling with this, guys. It's new stuff, and I just want to make sure you guys are doing okay and what I can do to help. Just going here. Okay. So this next one, I'm gonna have you guys try doing on your home. On your own, and it's a little bit more difficult because it's different looking. Okay, so I'm gonna have you guys try this one. I'm gonna give you guys a couple minutes to do this, and yeah, of course we're gonna need more help in the future. We're gonna spend 2 days on this. So this is day 1 of 2, and remember when I say 2 days, that's really 4 days, because we have today, and then tomorrow we're going to work on the homework in class together, and then Thursday is the second day, and then we're going to do homework in class on Friday. This new schedule is amazing. So if you guys need more practice and help, we're going to get it. Okay, so let's try this one out. This is a pretty cool problem, if I do say. Okay, and then we're going to have this. Okay, and there's going to be a 90-degree angle here and a 90-degree angle here. And we're going to label this as P, T, Q, and R. And this is a little bit of a challenge problem. Is triangle QPR similar to triangle QTP? So again, this is a little bit of a challenge. So we're going to challenge ourselves here. So now this is, yeah, it's an overlapping one, right? So, oh my gosh, I'm so glad you asked that question. So the first thing I would do, and I'm going to give us plenty of time to work on this. The first thing that I would do is I would draw these triangles out separately and label them. Okay. So draw these angles out separately and label them. And I can give you a hint. It involves knowing that some of these angles add up to something. We got some angle properties going on here, guys. Okay. Actually, no, it's a lot more simple than this. Sorry, a lot more simple. Just draw them separately. Sorry, this is a lot more simple than I thought it was going to be. So they are overlapping, so try to draw them out separately from each other. Man, we have some more time. We'll do a couple more practice problems. This is really good. I love having more time with you guys. And we're not going to need this much time, I don't think. So I'm going to cut you guys off at 1 minute. All right, we're going to go ahead and go over this now. So like I suggested earlier, try drawing these triangles out. So QPR, that's this big triangle. So just below this, I'm going to draw this big triangle or something that resembles it. Okay, and then I'm going to draw out QTP. So that's this one. And I might go like this and be like, hey, if you draw them in the same orientation, that might help. Okay, so because now when I look at this, what do they have in common? They have in common angle T and angle P, right? Right, that's given to us. They're both 90 degrees. But then take a look at this. Angle Q and angle Q. Right? They're overlapping again, aren't they? They're on top of each other. So angle Q would be congruent to angle Q by the reflexive property. Okay, so really tricky with that overlapping, right? We're going to have to keep practicing that and going from there. So I'm running out of time because I did say I want to end a little bit early just to get people who are on campus time to figure things out. Let's do one more problem. And it's a bit different than the ones that we've been looking at. So I'll give you guys a hint. This is not an overlapping problem. So this is not an overlapping problem. Okay, so this is not an overlapping problem. So this is 90, this is 32 degrees, and this is 58 degrees. And I want to know if triangle CDF is similar to triangle DEF. Okay, so not, again, not an overlapping problem. Be careful there. Be careful. All right, so I have to go over this. So let's go over this. So now we can do triangle sum theorem to get here, right? But we only have one angle here, right? We only have one angle here. So the first thing we need to take a look at is take a look at these two angles. This is a linear pair. And what do linear pairs do? Linear pairs add up to 180 degrees. So if this is 90 degrees, this has to be 90 degrees, right? So we already have a pair of angles there, right? So I used a linear pair. And then the angles have to add up to 180, don't they? So I can go like this, and I can say 180 minus 90 minus 32 is 58 degrees. Oops, should make an 8 out of that. There we go. Okay. So we have 58, 58, 90, and 90. So yes, I would use the triangle sum theorem, but I would also use linear pair. Okay, so I'm trying to get you guys just a little review of everything. So triangle sum theorem and linear pair. All right, it is 12:23, so I just want to make a couple of announcements. You guys will have second lunch every day. Okay, that's just what it is, because you will have me second period every day. Okay, so we have second lunch. So what that means is you are going to have lunch from 12:25 till 1 o'clock. Okay, so lunch is over at 1 o'clock. Really easy to remember. So at 1 o'clock, lunch is over. Your next class starts, your third period starts at 1:05. So again, you have lunch until 1, and then your next class starts at 1:05. Okay, so with that said, does anyone have questions about the schedule? There is no homework being posted at the end of this class. Next class, tomorrow, we will post the homework and we will work on it in class. I'll just give you time to work on it. Okay, so there's no homework tonight. When you guys show up tomorrow, we're going to have the homework. I'll be like, here's your homework. Everyone log into Big Ideas. Okay, so we will log into Big Ideas tomorrow and get that homework done. Does anybody else have questions about the schedule or what's going to happen with lunch? So again, it's a shorter lunch than we've been normally having. So just be mindful of that. It's only 30 minutes. We were having an hour lunch before. So it's only 30 minutes. So the lunch is going to go really quickly. If you're at school, you're going to go to the north side outside of the cafeteria to pick up your lunch. And I will see you guys tomorrow, okay? Bye, everybody.